In this video, we are going to study what is exactly a S-curve hydrograph. So, depending upon the various conditions, in basic hydrograph or in a simple hydrograph, that hydrograph might be produced because of the individual storm or because of the consecutive storm. Then L.K. Sherman had derived a new theory or had given a new research concept that uh, when we have two identical conditions or half of a rain, and when we have a two identical basin also, so the hydrograph that are produced from these basins and from these conditions, so it should be expected as the same. So he had given certain assumptions, and based on this assumption the unit hydrograph theory relies. And after this unit hydrograph theory, we can successfully apply this unit hydrograph theory, and we can derive the flood hydrograph ordinates as well as the direct runoff ordinates also. So let's start the S hydrograph analysis. S curve is a hydrograph that is produced by a continuous effective rainfall at a constant rate for indefinite periods. So here there is a third, we can say that this is our third condition and third uh, parameter. So on this the hydrograph, S-curve hydrograph depends. So what exactly S-curve hydrograph is? It is also a representation of a discharge versus time. It is a graph which shows the discharge versus time. The graph is known as a hydrograph. But why it is called as a S-curve? See, it produced because of the continuous effective rainfall. If rainfall will occurs continuous, having a constant rate for indefinite period. We don't know the for what period, or in the next 2 hours or in next 4 hours, 10 hours. We can't say that for what period that constant rate of effective rainfall will occur. So that type of a hydrograph which shows the continuous effective rainfall having a constant rate for an indefinite period is known as a S-curve. See, it is a continuous rising curve in the form of a letter S, capital S, till the equilibrium is reached. Hence, it is called as a S-curve, or it's called as a summation curve hydrograph. So at the time of a equilibrium, it will represent a constant rate of a continuous effective rainfall. So at a certain point or at a certain time interval, your rainfall intensity or your discharge value remains constant. You can study or you can see this in a numerical part. You will get the idea. The S-curve is constructed by adding together a number of unit hydrographs of a unit time duration spaced at a unit time duration. So for this, at the time of equilibrium, the runoff value or runoff discharge value will be given by Q, that is discharge, is equal to A, catchment area, into R divided by 36 Qmax. So the value will be, it will get or will be in a Qmax unit only. So let's see the diagram of this S hydrograph. See, in first diagram you can see that S curve which is plotted against time versus discharge, and you can see that this curve is a continuous rising one, and the equilibrium point is shown here. This equilibrium point, you have the constant value of a runoff discharge. So depending on this hydrograph, we can plot the effective rainfall diagram also. So at the above section, uppermost portion, the R0 centimeter per hour is nothing but the intensity of a rainfall, which can be get which can be this value can be get by plotting the time versus cumulative depth graph. So here the RO or RO value will be find out and will be calculated by analyzing this S-curve hydrograph. Then in the next diagram, you can see that how the S-curve hydrograph will be derived from unit hydrograph. As we had said that this S-curve hydrograph is constructed by adding together a number of hydrographs, a number of a unit hydrographs. You can see here the successive 6R unit hydrographs are shown here. So by adding together this number of unit hydrographs which is having a unit time duration means 6R is a unit time duration which is spaced at a unit time duration means see the hydrograph which is having a 6R time interval means what the hydrographs will be plotted at a equally spaced time duration. So the 6R unit hydrographs will be plotted and it is added afterwards. After adding the S-curve hydrograph will be the value of S-curve hydrograph coordinates will be taken out. You can see after adding this 6R successfully from the 0 up to the 78, we have 1, 2, 3, 4, 5, 6, 7. We have a 7 hydrographs, and when we are going to add this 7 unit hydrograph of a 6R unit interval, then we can get the S hydrograph value and which can be reached at the equilibrium point which is having a constant value as a Q is equal to 144 Q max. Certain points after this point the value remains constant, and at the above portion you will get the R value, that is effective rainfall value, as a 1 upon T. T means what? The unit duration of a unit hydrograph that you are going to plot, and afterwards you are going to add this hydrograph. That T0 means the time duration give us a inverse of this unit duration time gives us the intensity of a rainfall value. So this is how we can derive the S hydrograph. See this S hydrograph, basically the technique is useful uh, for deriving a unit hydrograph of a shorter or longer unit duration from a given unit hydrograph of a same unit duration. Sometimes what happened, the in the numerical unit hydrographs of a 2 hours is given, 2 hour unit interval is given, and they said us to find out the 3 hour or a 5 hour unit uh, duration or unit hydrograph, 5 hour unit hydrograph. So we know that the 2 and 5 it is not an integral multiple. So we can easily adopt this S-curve hydrograph when the uh, interval of a time it is not in the integral multiple, it is in the range of, it is not in the range of the integral multiple with each other, then we can easily adopt this S-curve hydrograph. Then when sometimes when it is said to be find out 24-hour unit hydrograph, when we want to find out the 24-hour unit hydrograph, and in the given we are given 6-hour unit hydrograph. So we know that the 6 and 24 it is in a integral multiple order. So 6 fours are 24. Okay, so because of this we can easily plot, and by lagging system we can easily find out the 24-hour unit hydrograph. So in this situation we cannot adopt this, or we can easily adopt this only a lagging system, and we can find out the unit hydrograph ordinates. In this situation it is not necessary to adopt the S-curve hydrograph. When the time interval, it is not in the integral multiple process, or when it is a shorter or longer period of a unit duration, from which the unit hydrograph of the same unit duration has to be find out, then in this situation the S curve hydrograph can be used. Thanks for watching this video.